I don't know if any of you have ever been at the airport when the flight attendants are asking if there's anyone willing to give up their seat to take a later flight. Usually they'll offer some type of voucher, hotel stay, a free flight, if you're willing to do that. I certainly have, and they do this because oftentimes they will overbook flights knowing that there's a chance people won't show up. There was a problem on the AP test a few years ago, one of the written problems that spoke to this scenario, and it asked students, I believe, to perform a simulation and then also figure out the theoretical probability that the flight will actually be overloaded. They overbook just a little bit, knowing people won't show up, so that they can make a little bit more money. Now, this problem 611 talks about the same type of scenario, but this is a van company. So the van can hold 7 passengers. They know that there is a chance that a passenger won't show, and so they're going to make 9 reservations and hope they're not overbooked. We want to know what the probability is that they're going to be in trouble, that they're going to have more than the 7 passengers that the van can actually hold. So we're going to assume that there's a 25% chance that a passenger doesn't show, because the problem tells us that 25 out of 100 times that happens. We're also going to assume that the passengers are independent of one another, so one person showing up doesn't have any impact on the others. I'm going to use my calculator to do this, and so I'm going to use 1 through 4 to create my 25% probability. I could have done 0 to 3. You guys know that you have options here. So I'm just calling 1 are no-show, 2 to 4 means they're going to show up. In order to simulate my repetitions, I've got my random integers. I want to choose them from 1 to 4 because those are the digits that I've assigned, and then I'm going to pick 9 of them because I want to look at what happens to all 9 people. So when I did this, the first set of numbers that came up for me was as follows. Let's make sure that's 9. It is. Okay. I'm going to create my 2 categories. So here I'm going to have more than 7. And here I'm just going to put not more than 7 for my other category. Again, so I can keep track of how many repetitions I've done total. When I look at this set here, my no-shows are my ones. So if I had 1, 2, 3 people not show up, that means I had 6 people that did. So this is in the case where I do not have more than 7 show, so we would actually be okay. The van company is not going to be overbooked and have some angry people. I'm going to continue to perform this operation in my calculator, tally them up, and then I will state my conclusion. Once I've done the appropriate number of repetitions, hopefully you've done 25 or so. In my case, when I did 25, I had 6 out of the 25 that ended up in the more than 7 category. And so that probability is 24%. And my final statement will say something like approximately 24% of the time, more than 7 passengers will show up for a van when 9 reservations are made. So the van company needs to decide, is that a reasonable probability? If I'm going to kind of tick people off 24% of the time, maybe we need to stop making so many reservations. Maybe we'll make 8 instead of 9. That concludes that problem and should hopefully give you a good idea of a few of the different types of simulation problems you'll need to be able to do in order to prepare for your quiz.